Students, welcome back. In 10th English medium, subject science 1, chapter number 4, effects of electric current. Now in this last lecture we have understand about the solenoid. I hope you have seen the last lecture, what is solenoid, and in today's lecture I'll also tell you how to draw the solenoid diagram. You can draw by from the textbook also, but still I'll show you the one method to draw the solenoid diagram. Now before starting that, first we'll understand the application of electromagnet, because in last lecture we have discussed about the electromagnet. What is electromagnet? Electro means electricity, magnet means magnetism. Because of electric current, the wire behave like a magnet. This property is called as electromagnet, and this was told by Hans Christian Ørsted, right? Now there are two types of electromagnet. One is a temporary magnet and permanent magnet. See, the temporary magnet, basically it is used in the cranes, okay, to lift the scrap which is there, which is made up of iron. So in that, temporary magnet are used. If a permanent magnet is used in the crane, the scrap iron once attracted cannot be detected, okay. So therefore we use a temporary magnet. Permanent magnet we cannot use, because we have to detach again the iron which has been attracted towards the magnet. So temporary magnet can be used, and it is very convenient. Temporary magnet can attract and detach as required. Storage of the permanent magnet of used size is difficult. We cannot store the used size of permanent magnet. It is a bit difficult. Permanent magnet are used in the speakers. Speaker contain the permanent magnet. It is required to give the tension to the diaphragm. Tension means force. And what is diaphragm? Is a vibrating membrane, you can see. This help in producing good quality of sound. Therefore we use this permanent magnet. Now let us draw the solenoid. How to draw the solenoid? Just see and observe how to draw the solenoid. First draw the 9 lines approximate. You can draw more than 9 lines also. It is not compulsory, but it's just a proper diagram you get according to this. If you draw 9 lines which is of 1 or 2 millimeter, see, the line should not in this way, it should be in this way properly, of equal measurement, okay. Then draw the coil freehand. You can draw this coiling in this way freehand, with the freehand. Draw the lines of force. Then you have to draw the lines of force, mixing together all these lines, okay. Connect all these lines in this way, you can see, right. Then draw the arrows, connect to a battery and plug key. Got it? This is how you have to draw. So it is diagram once again. In this way you have to draw the solenoid diagram. I hope it is clear how to draw the solenoid diagram. Draw the 9 lines of equal distance, and then do the coiling on that 9 lines which you have drawn. How much ever coiling you can do, 10, 15, whatever the coiling should be, you can do. Like orange color line which has been drawn, that is coiling, and then you have to join the each line. And then some lines, the center line you can show it as a straight line. This center line, keep it as a straight in this way, open, and keep one line in this way open, and keep one line in this way open. Actually it is not open, but we are showing that it is open, okay. It is closed everywhere. So this all are the lines of force, and show the arrow in this way, because this is the north side and this is south side. So from lines of force are starting from the north and ending at the south. Here also lines of force are starting from the north and ending at the south. Finally show this circuit, and then plug key. Or you can draw the as it is given in the textbook, as you like it, as you feel comfort. Clear? Now let's move further. Now let us understand the one new term, one new rule, that is Fleming left hand rule, which is very important. Why it is why we are studying this Fleming left hand rule? Because it is used in the application of electric motor. Once you will come to know what is electric motor when you will go further in this chapter. In that we will use this Fleming left hand rule to determine the direction of the motion of the conductor. So in that Fleming left hand rule are used, okay. So this is first of all Fleming's. Why Fleming name? Fleming is the scientist name, and you have to use your left hand rule. In that you have to use your 3 fingers, one thumb, one is the forefinger, and one is the index finger, a forefinger as well as the middle finger. forefinger also called as the index finger. Okay, so forefinger, index finger is considered to be the magnetic field, show the direction of magnetic field, and center finger show the direction of the current. This is about the left hand, not right hand. Okay, and if you know the direction of magnetic field and if you know the direction of current, then you can find the motion of the conductor. The thumb represents the motion. So three things you should know. It comes also in examination. The diagram of the picture of the hand will be given to you and you have to label it. It is there in your exercise question also, later you can see. So thumb represents the motion, index finger or forefinger represent the magnetic field, and the center finger represent the current. So how does the rule we have to write in the examination? Stretch the forefinger. This is your forefinger. This is considered to be the forefinger. Central finger. This is your central finger, and the thumb of your left hand. Mutually perpendicular to each other. They are all three fingers are mutually perpendicular to each other. Stretch the forefinger, center finger, and the thumb of your left hand mutually perpendicular to each other. If the forefinger show the direction of the field, now you can see this forefinger that show the direction of the magnetic field, and the center finger show the direction of the current. You can see this center finger that show the direction of the current. Then the thumb will point towards the direction of the motion of the conductor. Now in this Fleming left hand rule, what you have to know, so that the third thing you can find out. See, you have to know the direction of magnetic field, you have to know the motion, direction of the current. If you know the direction of magnetic field, if you know the direction of current, then you can find the third thing, that is the motion of the conductor. Very, very important rule. First rule we have studied, right hand thumb rule. Now this is a Fleming left hand rule we are studying. So once again I will read it. Stretch the forefinger, center finger, and the middle finger, thumb of your left hand mutually perpendicular to each other. If the forefinger show the direction of the field, that is magnetic field, and the center finger show the direction of the current, then the thumb will point towards the direction of the motion of the conductor. Thumb will give the direction of the motion of the conductor. Very important rule. Diagrammatic, they can ask you what is the thumb represent, what is the middle finger represent, what is the index finger represent. You should know the name. Or sometimes they can ask you directly the rule, state Fleming left hand rule. So you have to write this. Either you can write from this, or either you can write from the textbook, as easy you feel. Okay, it is same, one of the same thing. So this rule is going to used in the motor when we'll see the application of the Fleming left hand rule in the electric motor. Okay, so at that time I will explain you how it is applicable, how it is used. Now you have to just remember the three things. First, thumb represent the motion of the conductor, index finger represent the magnetic field, and the middle finger represent the current. If you know the direction of the field, magnetic field, and the current, then you can find the direction of the motion of the conductor, right? Now let us come to the motor. Now what is motor? You have heard about the different kind of electric motor. Electric motor may be of different size, some are small, some are tiny, some are very huge. You have seen that in toy car also different kind of motors are used. One such motors, it is given one picture also in your textbook. I'll just show you. See, this is a Fleming left hand rule that you have to study. It is given here also. According to this rule, यहाँ से आप लिख सकते हैं उसको. According to this rule, the left hand thumb, index finger, and the middle finger are the stretched as perpendicular to each other. If the index finger in the middle in the direction of the magnetic field and the middle finger points in the direction of the current, then the direction of the thumb is in the direction of the force of the conductor. You can write this rule also, or you can write the rule which I have shown you on the PPT right now. See, this is also one kind of motor. You can see there are different kinds of motor. There are the different shapes of the motor. But to represent the diagram on your book, okay, so we have represent the motor in a simple way. See, this is the picture which is given in your textbook, electric motor. This is it, how it look like, 3D diagram. So same kind of 3D diagram I have shown you in the slides also. Now I am going to show you. Okay, so let us understand what is electric motor, what is the principle of electric motor, what is the construction, how it is made, and what is the working of electric motor. All that I am going to explain you right now in this slide. Okay, so let us see. So first of all, we will see the definition of electric motor. What is the definition of electric motor? device which converts electric energy into the mechanical energy is called as electric motor. Very important definition. What is electric motor? A device which convert electrical energy into mechanical energy. Any electrical energy when converted into mechanical energy is called as electric motor. Example, fan. There are lots of examples are there. Fan required the electricity. When the electricity enter into the fan, where does that electric energy goes? They get converted into the mechanical energy, and due to that the fan start rotating. See, this is how the electric motor look like on the slide which you can see on your mobile screen right now. Okay, now this is the same diagram which is there. It in the textbook it is given in a 2D 2-dimension diagram. Now here it is in a 3 dimension, so it look little bit different, but in this way only the diagrams are there. Both are same only. And in the textbook there is a axial has been drawn. One axial is there between the ring. There is no axial here between the ring. Okay, so I will prefer you to draw the, if the diagram asks of electric motor in examination, so I will prefer you to draw the diagram from the textbook itself, which is there on the page number 56 of your textbook, figure 4.13, electric motor. So draw that diagram only. This is just for your understanding. So first we will see the construction part. What are the parts which are attached to the electric motor, basic parts which are there in every motor. So first is the armature coil. Now what is armature coil? A large number of insulated copper wire round on an iron core in a rectangular shape. This is a rectangular shape, you can see this one. This is a rectangular shape. Okay, this is a rectangular shape. This one, inside this one you can see this blue and yellow color plate, this rectangular, and here on that there is a wire which has been wrapped. You can see this wire, black color, you can see this wire. This black color wire has been wrapped. Wrapped means what? It has been coiled on this slab. So that is nothing but an armature coil. That's what it is written here. A large number of insulated copper wire around on an iron core. This wire के अंदर जो है वो iron core है in a rectangular shape. This is called as armature coil. Second is strong magnets. You can see here there are the two magnets have been kept. One is north pole and one is south pole. Now here you must be thinking which magnet has been used. You can use the horseshoe magnet also. It is in this way, right? Horseshoe magnet ऐसा दिखता है, right? इसके बीच में आप ये iron slab रख सकते हैं. So here one is north pole and here is south pole. Or you can use the simple, if this is the iron core, ठीक है, और इसके ऊपर ऐसा इस तरह से ऐसा कॉइल किया है जैसे ये डायग्राम में बताया गया. तो यहाँ पे एक मैग्नेट रखा गया है जिसे नॉर्थ पोल बोला गया और यहाँ पे एक मैग्नेट रखा गया जिसे साउथ पोल बोला गया. तो ये मैग्नेट का साउथ पोल कहाँ है? ये साइड पे होगा, और ये मैग्नेट का नॉर्थ पोल कहाँ है? ये साइड पे होगा. आर यू गेटिंग? वी कैन नॉट कट. मैग्नेट इज ऑलवेज डाइपोल, यू कैन नॉट मेक इन मोनोपोल. लेकिन ये मैग्नेट का साउथ पोल कहाँ है? ये साइड पे होगा, वी कैन नॉट सी दैट. और ये मैग्नेट का नॉर्थ पोल कहाँ होगा? ये साइड पे होगा. सो two poles of the magnet are kept between the on the side of the iron core. Next is split ring commutator. You can see the split ring commutator here. This is a split ring commutator, this one which I have circled, green color ring. You can see this is a split ring commutator. What does it do? It consists of two halves, R1 and R2. These are the two half radius, we can say. One is R1. There are the two parts of the ring. One ring they have taken and they have divided this two ring, single ring, sorry, and one part of the ring they have named as R1 and second part of the ring they have named as R2. Okay, of a metallic ring. Commutator reverse the direction of the current. Basically what is the use of this split ring commutator? It reverse the direction of the current. Thus, the reversing of current is possible due to the commutator. When the current can be reversed, reversing of current in the motor is very, very important. Okay, and this can be done with the split ring commutator. Now brushes are there. Finally, you can see there are the two brushes are kept, which is in the yellow color. One is B1 and one is B2, which is been attached to the split ring. Now two carbon brushes, which is made up of carbon, B1 and B2, are used to press the commutator. Now these brushes are used. These yellow color brushes are used to press the commutator so that the commutator can rotate very easily. Now we'll talk about the working. How does the this basically work? Now see, you can see here this is a coil, okay, and here they have wrapped a armature coil wire in this way. You can see this one. Okay, and they have labeled this as a rectangular. They have told this is a rectangular slab on which the wire has been wrapped, A, B, C, D. Correct. Now this coil is going to rotate. Now current will pass here current will start flowing from positive terminal to negative terminal. That means current will go from now see I am showing you the direction of the current. See, the current will start from here. It will enter into the B2 first. From B2 it will enter in this coil, and from this coil it will go from this R2 from R2 it will start from here. See that this is the direction of current I am showing. It will go from D to B, D to C, C to B, from B to A, and from A to it enters into the ring R1, and from R1 it enters to the B1, and from B1 it will come back to the negative terminal. Are you understanding how the current is flowing? Pay attention, very important it is. So current is going to flow in this way only. Now let us see when the current flowed from the armature coil A, B, C, D. Now when the current will flow at that moment, what happened? Basically this AB part move upward and CD part go downward. Okay, this you should know, this you remember these things. Okay, that's why see the working is given in your textbook also, but it is only in the theory part they have told, so you will not understand properly. But if you understand this flow chart, so you can write the working in your own words later in the examination if it is asked. Okay, so this you should know. So this you should know properly ki how to write the working. Basic concept you should know of the working. They does not ask you the working every time of the electric motor, but if they ask, so you can create your own wordings and you can write down. But you have to remember this flow chart so that you can write very easily then. Framing the sentence is required then, that's it. So current will pass through this coil A, B, C, D. Okay, so at that moment first AB will go upward, this portion AB will go upward and CD will go downward. Okay, so AB experience the upward force, and that means इसका मतलब क्या होता है? AB ऊपर की तरफ जा रहा है और CD नीचे की तरफ. इसका मतलब ये होता है कि ये तो कॉइल तो घूमने वाला है, तो जब कॉइल घूमता है तो AB ऊपर की तरफ जा रहा है और CD नीचे की तरफ. That means AB experience the upward force and CD experience the downward force. Both these forces are equal in magnitude. दोनों forces equal है magnitude में. Okay, that is in number. Okay, next vertical position. When this coil will rotate, obviously एक time ऐसा आएगा कि ये जब coil rotate होगा. See, now I cannot show you this rotating coil. Okay, because this diagram will not rotate. I'll share with you one video, that is animated video of this motor. In that you will clearly understand more detail that how does the coil rotate basically. Okay, in that you will come to know how does the coil rotate and everything. I'll share you that animated video later with you. Now just understand here कि when this coil will rotate, it will come in a straight position. At that time vertical position, what happen, this circuit will break. जैसे ये coil rotate करता है, यहाँ पे देखिए ये जब coil rotate कर रहा है तो इसके साथ ये वायर भी इसका joint ही है ना, वो भी rotate करेगा. इसके साथ ये ring भी joint है, split ring, ये भी rotate करेगा. तो ये जब रोटेट करेगा, जब वर्टिकल 90 डिग्री पोजीशन पे आता है तो कनेक्शन ब्रेक हो जाता है ब्रश के साथ से, कनेक्शन टूट जाता है. और जब कनेक्शन टूट जाता है ब्रश के साथ, सो व्हाट हैपन एट दैट टाइम, द करंट विल स्टॉप. वर्टिकल पोजीशन सर्किट ब्रेक्स बट द आर्मेचर डज नॉट स्टॉप ड्यू टू द इनर्शिया. लेकिन फिर भी वो जो कॉइल है वो घूमता रहता है. जैसे एग्जांपल आपका पंखा, फैन ऑफ योर हाउस, व्हेन यू cut the power of the fan, then also the fan rotate for some time and then it come to stop, rest position. Why? Because of inertia. वैसे coil भी घूमता रहेगा और जैसे current बंद हुआ फिर भी coil घूमेगा. Okay, because of inertia. So vertical contact break at this position. Next it will continue to rotate because of inertia and it will complete all the angles. It will start with the 90 degree, then 180 degree, 270 degree and 360 degree, and this whole coil will rotate and it will again connect to the circuit. Again it will connect to the brush, and that this time AB will again, the AB will be upward position, experience the upward, and CD will be downward. Okay, AB and CD are what? They are the coil. Okay, iron coil. Okay, this is a AB and CD are basically the wire which is wrapped around the coil, iron coil. Okay, that is only called as armature coil, right? So after completing one all full 360 degree rotation, एक पूरा सर्कल कंप्लीट करने के बाद फिर से AB ऊपर जाएगा और CD नीचे आएगा, and the direction and the process will be continue in this way. So once again you should know all these things about the electric motor. This is a short description which I had given in the slide. I will suggest you to just go through once again in the textbook, read it that also. Now then you will more able to clear about this working of the electric motor. Surely I will share with you one animated video also, so that you will understand more detail how the electric motor actually works. This is just a theory part. Practically part I will share you with the help of animated video. Okay, so once again I will tell you, when the current, these are the construction part, this is a definition of electric motor. These are the construction part, that is armature coil, strong magnet, split ring commutator, brushes, and then this is the working part which is given in the flow chart. Remember this flow chart, frame your sentence in your own words you can do. So first the current is flowing from A, B, C, D, and when the current is flowing from A, B, C, D, AB will upward and CD will go downward. Okay, and then a vertical contact will break when it comes to the 90 degree, but still the coil will keep on rotating because of inertia, and again it will come back, connect with the circuit, and it will complete a full circle, that is 90 degree, 180 degree, 270 degree and 360 degree, and finally again the current will pass through this coil, and AB will move upward and CD will move downwards, and in this way the cycle goes on continuously, and in this way the coil keeps on rotating. In more things students, in this which we have studied right now, the construction of electric motor, one more question is there, why does AB move upward and CD move downward? Because there is a force which is acting. Okay, and this force can be determined, this motion of the conductor. How we come to know that AB is moving upward and CD is moving downward? This can be helped to determine, this can be determined with the help of Fleming left hand rule. Remember what is Fleming left hand rule? Fleming left hand rule, what does it say? Stretch the four fingers, index finger and the middle finger and the thumb equally, which are mutually perpendicular to each other. Then if you know the direction of magnetic field, यहाँ पे आपको magnetic field का direction पता है क्या? Yes, we know the direction of magnetic field. North से south जा रहा है ना, lines of force ऐसे ही जा रहा है. Direction of current पता है? Yes, we know the direction of current also. So can I find the motion of the conductor? Yes, you can find the motion of the conductor by using the Fleming left hand rule. So from this we come to know that AB is moving upward and CD is moving downward. So from this we can also in this working of the electric motor we can apply the Fleming left hand rule, and we can find the motion of the conductor कि motion of the conductor कैसा हो रहा है. यहाँ पे तो ठीक है, चलो डायग्राम से आपको पता चल जाएगा कि AB ऊपर की तरफ जा रहा है, CD नीचे की तरफ, या आप याद कर लेते हो sometimes. But actual में if you see the motor, then how does the motor rotate? It rotate in a coiling form, right? But the motion होता है उसका rotation of the when the motor rotate. So when the thumb is pointing upward, that means motion of the conductor is upward, and if the thumb is pointing downward, then the motion of conductor is downward. So this is how the Fleming left hand rule is applied in the electric motor. Okay.